Good afternoon, dear student. Welcoming you all to my YouTube channel Learning Agent. Today I am here with you with the numerical solutions of chapter 8 Physics 8a video 2. Before going to this video, please go through my first video, the links which I have given in the descriptions. So let us start this video without any delay. The first question here is 9, and here I am solving the question from 9 to 13. In the previous video, it is video number 1, you will get the solution for the numericals from 1 to 8. So here you see in this question it has been given that a given wire of resistance 1 ohm is stretched to double its length. What will be its new resistance? Here you see in the figure the first one, that is this one. Here this is the initial position of the wire. Suppose the length is L. So if the initial length is L1 and after stretching the same wire, if the length is L2 up to this, so definitely the cross section area will reduce. So if it is A1, the cross section area of this will be A2. So here the relationship, one relation is there. If the length is double, then the cross section area becomes half. So here I can write A2 equal to A1 by 2, means A2 by A1 equal to 1 by 2. So how this has come, I am showing you. Here see the material is same, so the volume in both the cases will remain same. So if the volume is V here, I can write volume will be equal to A1 into L1, cross section area into length. In this case also V will be equal to A2 into L2. So if I equate this A1 into L1 equal to A2 into L2, and I am getting A2 equal to L1 by L2 into A1. So here L2 equal to 2L1. So if I cut L1 and L2, we get A1 by 2. So A2 will be equal to half of the initial cross section. Now in the question it is given that initial resistance R1 equal to 1 ohm. That is, for this wire the R1 equal to 1 ohm given, and for this wire what is R2 we will have to find out. The length L1, if the initial length L1 and the length of the second wire, second position is L2, then we have already find out that L2 equal to 2L1. Now we know that a formula is there for finding out the resistance. It is resistance equal to rho L by A, where L is the specific resistance of the material, rho is the specific resistance, and L is the length, A is the cross section area. So we can write down resistance 1 R1 equal to rho L1 by A1, and R2 resistance of 2, that is second position, rho L2 by A2. So if I combine this, I can write, if I divide this R2 by R1 equal to, I can write rho L2 by A2 rho L1 by A1. So we get, after cutting rho will get cancelled because rho is the same for this material. So this is coming L2 by L1 into A1 by A2. So L2 is 2L1. So L1 is here, and A1, A2 is A1 by 2. So if I cut this L1, L1, A1, A1, we are getting 4. So I can write finally R2 equal to 4 into R1. Again R1 is given 1 ohm. So finally we are getting 4 ohm. So the answer is 4 ohm. So this is for understanding. You can find out the final solution here. This is the final solution. You see the answer is 4 ohm. So you can write it down. I hope you have understand the basic. Now go to the next question. Question number 10. Here a wire of resistance 3 ohm and length is 10 cm is stretched to length 30 cm. Assume that it has a uniform cross sections. What will be the its resistance? Here you see also the same. It is similar to the previous one. So here the same case, if the length initial wire is L1 and after stretching the length become L2. Here you see L is given, L equal to 10 centimeter, or L1 is 10 centimeter and L2 equal to 30 centimeter. So how much it has been stretched? It has been stretched 3 times. You see L2 by L1 equal to 30 by 10 equal to 3. So in the earlier solution I have shown you that if the length becomes doubled, area becomes half, and now so if the length become tripled, area will become 1/3. So if the cross section area of this wire is A1 and of this wire is A2, so I can write A2 equal to A1 by 3. The derivation I have shown in the previous numericals. So here we will apply the same formula. We know the resistance equal to rho L by A. So I can find out the resistance R1 equal to rho L1 by A1 and R2 equal to rho L2 by L2. Here you see R1 is given 3 ohm, and we will find out R2. So this is R2, this is R1. If I divide R2 by R1, we get R2 R1 equal to what? Rho L2 by A2 rho L1 by A1. So on simplification, rho will be cancelled. So here I will get L2 by A2 into A1 by L1. So if I put here L2 by L1 is 3, so I can put L2 by L1 into A1 by A3. So it will be 2. This is 2, and this portion is how much? This portion is let us simply put A1 this will be A2 will be what? A1 by 3. So A1 get cancelled. So this is coming what? It's coming 2 into 3. It is 6. So no, L2 by L1 is 3. I've written something wrong. So it is 3. So it is coming 9. So it's coming 9. So that means R2 by R1 I am getting 9. Again R1 is 3. Here I have written. So if I put R2, so R2 equal to 9 into 3 equal to 27 ohm. So answer will be 27 ohm. So you can see the final answer. This is the final answer. So hope you will got it very easily and understand it. Now go to the next. Here in this see, here again a wire of resistance 9 ohm having length 30 cm is tripled on itself. Tripled on itself. This is students get a little bit confused on this. What is tripled? The length is tripled, or the size of the wire is tripled. That is the cross section area. Now here tripled on itself means the cross section area is tripled. That is the wire become thick. This is the initial position of the wire. See, if the initially the length of the wire is L1, so finally it become, if it is L2, here the cross section area, if the cross section area A1 and this is A2, as per the questions A2 will be 3A1 because it has been tripled, not stretched, it has been tripled, shortened. So here area is, cross section area is tripled, so obviously the length will become 1/3. So I can say here L2 will be L1 by 3. So what is given here? Given the resistance of the first is 9 ohm and the length is L1 equal to 30 centimeter. Here the length is not given. Length let's the resistance is 2. So as per the formula, resistance equal to rho L by A, we know that you can write down R1 equal to rho L1 by A1, R2 equal to rho L2 by A2. So dividing R2 by R1, we get rho L2 by A2 rho L1 by A1. So finally on simplification we get L2 by L1 A1 by A2. So L2 by, in case of L2 you can write L by 3. In case of A2 you can write 3A1. So A1 get cancelled, L1 get cancelled. Finally we are getting 1 by 9. So we can write R2 equal to 1 by 9 into R1. Again R1 is given here 9 ohm. So final answer is coming 1 ohm. So hope you are clear. Now this is the complete solutions. Hope you will get it. So you pause the video and write it down. Now let us go to the next question. So next question is, what length of a copper wire of specific resistance 1.7 into 10 to the power minus 8 ohm meter and radius 1 millimeter is required so that its resistance is 1 ohm? Here you see, here we have to find out given. What is given? Given, I am telling you that once you write down the given data, the problem gets solved half. You can practice it. So here given data is specific resistance, that is rho. Rho is 1.7 into 10 to the power minus 8 ohm meter, and the radius r of the wire equal to 1 millimeter. So we have to take it into meter. So into 10 to the power minus 3 meter. Now, because all are given in SI unit, and also the resistance R equal to 1 ohm. So simply put the formula. We know resistance equal to rho L by A. So here rho is given 1.7 into 10 to the power minus 8. L is not given. So if L is L and A, what is A? We know A equal to pi into R square. So it will be 1.7 into 10 to the power minus 8 by pi is 22 by you can use 22 by 7 or 3.14. So if I use uh, instead of this, if I use 3.14 into R is what? R is 1 into 1, that's not 10. It's 1. So 1 into 10 to the power minus 3 whole square. So finally we are getting, upon simplification, 1.7 into 3.14 into 10 to the power minus 8 upon 1 into 10 to the power minus 6. So if I take this like this, 1.7 by 3.14 into, I am getting 10 to the power minus 2. So finally upon dividing this, we are getting 1 point, we are getting what? We are getting 1, 8, 4, 7 into 10 to the power minus 2 meter. So finally we are getting 184.7 meter. So what is that? There is some mistake, I think. If I further calculate, this is like this. This, see here it's coming like this into, we did not rewrite the L. There is L also. So finally you can write this is equal to into L. This is equal to what? R is given 1 ohm. This is 1 ohm. So finally I can find out the L is 3.14 into square divided by 1.7 meter. So if I calculate it, we will get 1847 into 10 to the power 10 square meter. So finally it will come 184.7 meter. So the length of the wire will be 184.7 meter. So let's see the final solutions here. Yeah, so this is here. So after understanding, you can now write it down. So now let us go to the next questions. This is the question number 13. The filament of a bulb takes current 100 milliampere when potential difference across it is 0.2 volt. When the potential difference across it becomes 1 volt, the current becomes 400 milliampere. You see here, if the potential difference increases, the current is also increasing. So calculate the resistance of the filament in each cases. So here I am seeing that given, I'll suggest you first of all write down the given data. Given first case, this one, when voltage, it is potential difference, voltage V1 equal to 0.2 volt, then current I equal to 100 milliampere, that is 100 into 10 to the power minus 3 ampere. In case 2, when V2 equal to 1 volt, current I equal to 400 milliampere, that is 400 into 10 to the power minus 3 ampere. So what is the resistance? So if I apply Ohm's law, that is V equal to IR, we can find out the resistance in every case. So in first case, R1 is coming V1 by I1 equal to, so I1 is I2. So I1 is V1 is 0.2. So I1 is into 10 to the power minus 3. This will come 1 ohm. This will come what? Not 1 ohm. This will come 2 ohm. This will come 2 ohm. Now R2 equal to V2 by I2. So V2 is 1 volt by 4 into 10 to the power minus 3 ohm, 400. So it will come 100 by 400, 0000 cancel from 2.5 ohm. So here you see R2 greater than R1, that is resistance has been increased. So calculate the resistance of filament in each cases, find out and account the difference. Why the difference is coming? The difference is come because of increase in resistance, increase in heat. We are applying the voltage and increase the voltage, so there will be a increase in the temperature of the conductor. So we know that if the temperature increase, the resistance also increases. That's why in second case resistance is increased 2.5 ohm. Please find the result here. So this is the final result. So hope you understand all the numericals I have solved. If you really find it useful for you, please subscribe my channel and also forward this video to your friends so that they can get the benefit also from this. So today is no more. Thank you for remaining with me. Thank you. Bye bye. I will see you again in my next video.